Today we're looking at adding and subtracting more complex algebraic fractions. Okay, they're more complex because of how they look, but the process remains exactly the same. I still want that common denominator, and in this case my common denominator is 10. Okay, now I have to think, how did I go from 2 to 10? Well, I multiplied by 5. So that means that I need to take the top of my fraction and multiply it by 5. So 5x plus 1. And then how did I go from 5 to 10? I multiplied by 2. So then I have to do 2x minus 3. This is going to add an extra line of working for us. We're going to have 5x plus 1 over 10, 5x plus 5, 5x plus 5, plus 2x minus 6 over 10. And now, again, we're adding those top lines, but we're trying to collect our like terms. So 5x and 2x is 7x. 5 minus 6 is minus 1, and that's all over 10. Okay, this time we have the algebraic terms on the bottom, but again, this does not change what we do. Okay, I want my bottoms to be the same, so that means that I'm going to have my bottoms as x minus 1, x plus 2. Taking both those and just multiply them together. Okay, so this bit is going to be a wee bit trickier. What did I multiply x minus 1 by? Well, I multiplied it by x plus 2. So I've got to do the same to the top. 2 sets of x plus 2. For this question here, we have 4 over x plus 3 over x minus 5. Okay, we're still going to start our process the exact same way and get that matching bottom. So x minus 5 on both. So now I'm thinking, what did I do to x to make it x minus 5? Well, to make it x minus 5, well, I multiplied by x minus 5, so that means on the top I'm going to have 4 x minus 5. And then here, what did I do to x minus 5? Well, I multiplied it by x, so then I have 3x. Multiplying out that bracket, I get 4x minus 20 over x minus 5 plus 3x over x minus 5, and then tidying up, 4x plus 3x is 7x, so 7x minus 20 over x minus 5. And finally, what happens if you have algebraic terms both on the top and the bottom of your fraction? Well, you start off by doing everything exactly the same. We have 3x plus 1 on the bottom of both of our fractions. Okay, so how did I go from 3x plus 1 to x 3x plus 1? Well, I have multiplied by x. So I'm going to be doing the same to the top. So I'm going to have 5x squared. And then how did I go from 3x plus 1? Well, I've multiplied by 3x plus 1. So I'm going to do the same to the top. So I'm going to have 3x plus 1. Okay, so tidying this all up, I have 5x squared over 3x plus 1, minus, and then I have 6x, and then now I have to watch for my negative because I have a minus and then a plus, so that's going to play a part in the next line, but I've got 6x plus 2 all over 3x plus 1. So collecting all of our like terms and putting into a single fraction, I have 5x squared minus 6x minus 2, all divided by 3x plus 1.